So, Professor Frazzoli, I'm very excited to have you here. For those of you who are not aware of who he is, he's a professor of dynamic systems and control at ETH Zurich. He's the co-inventor of the RRT star algorithm. He founded the self-driving car company Autonomy, which put autonomous taxis on the roads of Singapore as early as 2016, and was later acquired by Aptiv. Autonomy is now known as Motional, which is a joint venture between Aptiv and Hyundai, and of which Emilio Frazzoli is currently the chief scientist. Once again, thank you very much for being here, Professor Frazzoli. I will now turn it over to you.
Yeah, thank you very much for the introduction. Small correction, that is actually, I stepped down from my role as chief scientist of Motional as of yesterday. So this is my first day back in like a full-time in academia. So, but definitely, this has been a very interesting experience, for me over the past few years. Now, what I would like to do today is a little bit of a reflection on what in all these years, we face a number of challenges, but what I think of today as really what is the biggest challenge for autonomous vehicles. So the talk will actually be quite different, probably. I think that I don't have a single formula in it, right? So this will be more, thinking about what is the big picture, what are the important problems, and how we can address them. As I was putting together the talk, I actually went through some of my old footage. This is actually footage from 2012 or 2013, where we started doing this work on autonomous cars, or in this case, you see that is autonomous golf cart in Singapore. And we were thinking of that as some device to provide autonomous mobility on demand services. Fast forward a few years, and what you get is is actually this footage, much more professionally produced. This was about a year ago from Aptiv, and essentially the point is that these things are coming. In just a few years, we went from that golf cart held together with duct tape and string to a really professional operation. We gave more than 100,000 rides, paid rides, to customers, to Lyft customers. 98% of them rated the ride with 5 stars out of 5. So this is something that is being more and more successful, and the technology is maturing and hopefully will be ready soon. Now, in all these years, clearly we had to face a number of challenges, like how to work on perception, control, planning, hardware integration, all the fleet management, the operations, and so on and so forth, right? What are the key things? Now, typically when people talk about autonomous vehicles, one of the first things that come to mind is safety. Now, if you ask me, that's not necessarily the main benefit. It's definitely a big benefit, right? But I think of it as not necessarily as the main benefit of the technology, but is a threshold, kind of like a barrier, in the sense that unless we can show that this vehicle, this technology is sufficiently safe, whereby sufficiently safe is something to be determined, it will be hard to introduce this as something that will actually be used. It will be hard to get public acceptance, it will be hard to get, regulatory approvals, and so on and so forth. Okay, so everybody talks about safety, right? Now the problem is, what does safety mean? Okay, so I think that anybody you ask will agree that safety, of course, we need safety, right? So, and you will see that all people who work on autonomous vehicles, they will say, oh, the first thing for us is safety. But then if you ask them, okay, yeah, fine, but what do you mean exactly by safety? Oh, I should not hit people. Okay, fine. But let's say that you're driving on a high-speed road, like on some arterial, and then you see somebody who is approaching the curb and may be intent on crossing the road, even though he shouldn't. What should you do? I mean, you are traveling fast and traffic is traveling fast. Should you slow down just in case this person decided to cross the street or not? And, these are kind of like, unresolved issues. But anyway, so in general, safety as prevention of unreasonable risk of driving is typically ensured by, first of all, you certify vehicles and drivers, and then you establish some rules for interaction protocols, rules of the road, and then you have some form of enforcement, right? Now, the problem with this is that while everybody kind of like goes by these rules of the road, something that is not, immediately evident is that these rules actually are far for providing a sound theory for driving. Let me give you an example. There is something in all regulations. So here, my favorite example is actually from the Swiss traffic laws. And here, this is translated from the Italian version to English by me, okay? So maybe the legal language is not exact, but there is something that's called the fundamental norm. It's actually article number 3. And it says, all road users must behave in such a way not to pose an obstacle or a danger to other road users. Fine, I mean, nothing to object about that. But actually the law goes on by saying other road users that behave according to the rules. That's interesting. So what if somebody does not behave according to the rules? Then what am I allowed to be an obstacle or a danger to them if they don't follow the rules? I mean, for completeness, the law actually goes on, says, by saying that special care must be exerted in the presence of children, disabled, elderly people, and when there are reasons to believe that a road user is not behaving correctly. But you see that now you have a lot of room for some kind of discretion or some reasons to believe that somebody's doing something, and then you had to exert some kind of like a special care, right? So you see that the language is more and more fuzzy. So even though claims of safety are ubiquitous, there is no clear specification of what safety means. So rules of the road are written by humans for human consumption, often based on legacy. So I don't know if, maybe not all of you know that actually the rules of the road that we use today actually come from the rules that were originally written for controlling herds and flocks of cattle, right, or sheep, when they're traveling on roads with humans. So as such, the rules are incomplete, they're not technically precise, times are contradictory, and always open to interpretation, okay? So something else that you should keep in mind is that it is actually legal to break the law, to the rules of the road in order to ensure safety, or conversely, it is illegal not to break the law in case you need to do it. Of course, this is kind of like a paradox, right? But there are, we have to understand in what ways it is actually legal to be illegal, right? So essentially, the point is that AVs must demonstrate an internalized, what is called a reasonable level of care. Okay, so for example, in the American legislation, essentially what you have to, the standard is what a reasonable person would do in that case. And you see, but what is the definition of a reasonable person? I don't know, right? But essentially, this is, at this point, you go to court in front of a judge and make the point that you are, or your system behaved as a reasonable person would. Okay, so then, whenever there is something that goes beyond the actual regulations and the mathematical or technical specification that you may have, people call upon ethics, right? So as some kind of like a deus ex machina, as something that will resolve and will allow humans to exert their common sense and their reasonable reaction to decide which rules can be can take precedence, or which rule can be violated for the purposes of pursuing some higher goals of avoiding dangers and ensuring safety, whatever that means, for other people and other actors on the road. Okay, fine. Now, it is very unfortunate that ethics is really important in trying to understand, go beyond what are the limitations of existing rule sets or other specifications that are available, right? It is unfortunate that whenever you talk about ethics and autonomous vehicles, people start talking about what are known with the, under this definition of like a trolley problems, okay? So now you have your car barreling down the road, and now you had this option. So if you go straight, you hit and kill 5 children. And if you make a maneuver, an avoidance maneuver, maybe you, instead of hitting the 5 children, you hit this elderly gentleman on the side of the road. Okay, so what do you do? And then usually when people ask me this question, it's kind of, I get back to them and say, okay, so fine, but then what would you do in this kind of situation? The problem is that these trolley problems focus on high stakes, highly constrained, very unlikely situations. And they set up the problem in such a way that it has perfect information and has deterministic outcomes. All of which make for very interesting, very entertaining cocktail party kind of conversations, and clearly very interesting philosophical discussion. But the point is that this is actually not very useful for what we need to do, okay? And actually, we recently published this this article on the proceedings of the National Academy of Science, where we try to go beyond these trolley problems and driverless dilemmas to more practical common sense tests for whether autonomous vehicles are actually safe or not, okay? And let me go through some of the criteria that I think are actually important and need to be addressed when we think of what are the acceptance criteria for these vehicles, okay? Before we start thinking about those trolley problems, okay? Again, this is not to say that those trolley problems are not important, but the problem is that there are so many other problems which are way more important that we should not be distracted from thinking about those. First of all, we need to quantify common sense. So many situations are actually not dilemmas, but they just lack a precise and quantitative formulation. For example, a lot of the rules of the road are predicated upon a concept of right-of-way, okay? When you approach an intersection, blah, blah, then you had to yield right-of-way to cars that are coming from the other, other roads. Okay, so can you explain to me what exactly is right-of-way? Under what conditions should I yield to somebody? And I know that I had to yield to them, right? But how far and how fast should they go in such a way that I'm allowed to cross their path versus waiting for them? Okay, so there is no definition of right-of-way anywhere. Literally, I mean, I've searched all over the world for a precise definition of right-of-way. There is none. Okay, so what we did is, I don't know if you can see my pointer, but on the right-hand side, what you see is we just did the data collection campaign, just some observational study. And then we went to a T-junction, and then we had our car sitting on the side of the road and, measuring where cars were coming in and, traveling through this intersection. And what we saw is that the purple points are the instances where we chose to wait, okay? The yellow are the instances where we chose to actually proceed through the intersection. And you see that there is no clear boundary between these two. So even humans have very different notions of what right-of-way means, okay? So what we did is in our car, we designed our logic for going through a T-junction in such a way that essentially we yield in the majority of cases where a human would have yielded, right? Not all of them, but also we proceed with the intersection when most humans would do that, okay? Now, you see that this is an instance in which we go from some nebulous or conceptual definition of a right of way to something that is specific. Okay, so we will yield under these conditions, if the oncoming cars are approaching at a certain velocity at a certain speed, and then we will proceed through the intersection in other cases. Okay. Now, this kind of uncertainty includes many other notions. So, for example, we know that we should give some clearance to pedestrians or to cyclists on the road, right? So you don't want to get too close to a cyclist, for example. But how far is far enough? Nobody knows, okay? Under what conditions are you expected to yield out of courtesy, in some sense, versus what other conditions you're not really expected to, so on and so forth, right? Or how to adjust to unlawful behavior by others. So, for example, a common criticism of autonomous vehicles is that they tend to stick to speed limits. Okay, but everybody knows is the speed limit is, say, 60 miles per hour. Everybody's traveling at 65. So if you have an autonomous vehicle that's traveling at 60, it's slowing down traffic. But yeah, okay, but it's following the law, right? So, but then how do you get out of that? So, for me, these are all things that can be resolved by clarifying the norms. Do we want to enforce the speed limit? If yes, then complain about cars going at the speed limit, or do we allow some deviation? Do we want to increase the speed limit? Let's clarify that and then go with it. In other cases, you can just collect data as we did and just go with these results from this data-driven campaign. We also actually have an initiative called like a reasonable crowd, where we, instead of just looking at this idealized reasonable person, what we do is collect data from very large groups of people and hope that this crowd is actually a good model for the reasonable person. Okay. Next thing is, we should really focus on low stakes versus high stakes scenarios. What I call the mother of all driving dilemma is actually not that interesting. Is actually what you should do when you're driving and there is a car that is sitting in your lane. This car, maybe is parked, right? And then you need to get into the other lane, but of course you want to do that safely, right? So again, there is nobody that tells you exactly what to do in that case. The reasoning is that it's okay to get into the other lane, even though you shouldn't, as long as it is safe to do that, right? And it allows you to make progress. But now, this is a problem that is unexpectedly much more difficult to resolve appropriately than I ever thought it would be. Okay, so we spent years looking at this, and if you, I think that this is one of really the key points. If somebody does it well, it means a lot. Okay, there are a number of questions. So, for example, when is it that a stationary vehicle is parked versus it is momentarily stopped? For example, to yield to a pedestrian, or maybe because there is a traffic light ahead, or things like that. How much should you stay away from that obstacle, or how much you should get into the other lane? What you should do when there are other vehicles, okay? And you see that, here in this case, I'm not choosing to kill 5 children versus like an elderly gentleman, right? So I'm not choosing about life and death. I'm choosing about, how much do I violate one rule versus how much I violate another rule, right? And this is what I mean as a low stakes scenario. And this is a scenario that I encounter many times a day while I'm driving, right? Versus those trolley problems that maybe are once in a lifetime kind of scenarios. Then there is the notion of dealing with uncertainty. Okay, so let me pose you this problem. Okay, so this is what I think of as a well-posed trolley problem. Okay, so let's say that you're traveling down the road, and then there is somebody who crosses the street, crosses your path when they shouldn't. So this is not on a crosswalk. This is somebody jaywalking, right? So if we keep driving, keep doing what we're doing, with probability 1, we hit them. Okay, but it's not our fault, right? Because they were crossing the road when they shouldn't. But we can do some kind of evasive maneuver, okay? With the evasive maneuver, with probability P, we hit a pedestrian, or maybe we slam the brakes and we are rear-ended by somebody, okay? So with probability P, we hurt somebody else, but this is not our fault, okay? Now, clearly the choice here of the, let's say, the safest thing to do depends on the value of P. And in particular, if P is 1, okay, so if by doing an evasive maneuver, we harm somebody else for sure, at that point, we prefer, not to take the evasive maneuver. At least we hit a person that was looking for it, right? So he was doing something that he was not supposed to do. If P is 0, that is, if we take an evasive maneuver, we don't cause any harm to anybody, then clearly we will choose B. Now you can have somewhat of a continuity argument, and that there must be some value of P, let's call it P star, at which we cross from one decision of just keep going versus taking the evasive maneuver. How do we compute that decision threshold? Who decides that decision threshold? How do we assess what that probability is? And we make this problem a little bit more interesting is when we bring into the picture the fact that there is a perception that is noisy, okay? So now reformulate this problem as we think that there is a pedestrian in front of us with probability Q, right? So then if we go straight with probability Q, we hit a pedestrian, but it's not our fault. If we take an evasive action, even in the case there was no pedestrian in our path, we still, with probability P, we hit another pedestrian, and it's definitely our fault, right? So now again, now the decision is a function of P and Q, right? If P is equal to 1, we definitely prefer A. If Q is equal to 0, we prefer A. If P is equal to 0 and Q is equal to 1, we prefer B, right? So again, where is the decision threshold in this case? Okay. So this is a summary of a number of guidelines that we developed for, how should we test an ability of the ability of an AV to drive with common sense. A few things that we described: test common sense, use low stakes scenarios instead of high stakes, in addition to high stakes scenarios. Acknowledge the fact that you have uncertainty, acknowledge the fact that you have limited information. Sorry, I cannot access the CV of every person, or the criminal record of every person that I encounter over the on the road, right? So to make decisions, we need to acknowledge that there are trade-offs, and I think that the big point here is that what we want to do is rank principles, really understand why we are making some decisions versus state what are the right outcomes in any given solution. Okay. Now, who is telling us all these things? Unfortunately, the fact is that ethics transcends the purely technical sphere. So it is not up to me, should not be up to me as the technology company to decide what are the right thresholds, what are the right specification, all these things. This is something that should be really the outcome of, should be really decided by society through their elected or appointed representatives, right? So it's really something that is up to the people representatives in the lawmaking organization or institutions to come up with these policies and technical regulations and so on and so forth, right? Of course, at a technology company, we can facilitate this process by pointing out what are the main difficulties, criteria, and how we can, what are the options that we have to address all those things. In addition to safety, I think that there are a number of other features that we want to have in autonomous vehicles. This is safety. We want this vehicle to be predictable. We want them to behave in some form of like a reasonable way, as I was mentioning before. We want them to behave in a uniform way, right? So, faced with similar situations, we want them to behave in similar ways. we want them to be comfortable, right? So not be physically unpleasant or surprising, right, in their behavior. And also we want them to be explainable, right? So we want to be able to explain why the vehicle made some choices and why it reacted in some ways. Okay, so how do we actually do that? Typically, approaches in engineering, right? So in the technology to develop this kind of cars have followed, there is the traditional approach where what you do is develop some very complicated algorithm and logics. If this happens, then do this, under this condition, do that, and so on and so forth, right? So this is something that takes a lot of human insight and expertise, years of work, several PhD theses, but still something that is is very complicated to do. Now, recently, people have started looking at more like a data-driven and learning-based approaches. So essentially, people say, well, let's collect a lot of data. Let's collect, lots of data from good drivers and showing us what a good driving is, and then we develop our control system for the car using this way. Now, my criticism for this is that both of these approaches are actually very complex systems that are very hard to debug, validate, and verify. And perhaps primarily, they're very hard to fix in case a defect is found, okay? So how do we go around this? And as I was saying, so complexity is a limit in both cases, right? On one hand, if you are trying to develop a very precise logic, then the computational complexity, really hits you, because now the number of cases that you have to face scales exponentially with the number of rules that you have to implement. Okay, same thing for global optimization-based approaches. So now what you have is your global optimization had to deal with local minima, and how to make sure that you're not stuck in a local minimum. Again, computational complexity goes up very quickly. In the case of learning, still, you have sample and model complexity issues, right? So how do you make sure that you have enough training data, training example in each one of those exponentially, combinatorily large number of corner cases? Debugging all these systems is, really, we don't know how to do. And then what if you find a problem? How do you fix it? For example, how do you fix a problem that you see in a learning-based system? Well, usually the answer is, well, let's collect more data and cross our fingers and hoping that with the new additional data, we are actually able to resolve that particular encounter. Okay. I would take a step back, right? So, and think about what we do with humans. Okay, so and I think of this as a accountable intelligence, right? So, how do we teach humans how to drive, and how do we certify their driving ability? So essentially, we don't trust their experience, right? So it's not that we tell somebody, oh, you've been driving around for 10 years, here is your license, right? No, we don't do that, right? And we don't tell them exactly what to do in any possible situation, because just that, too many possible situations to enumerate. So what we do is we publish and we agree on the rules of the road, including best practices and things like that your dad or your mom can teach you when you're learning to drive. And then we hold them accountable to those, right? So we check their physical and cognitive ability to comply with the rules of the road. We test them, their knowledge of the rules of the road by a written exam. We test them their physical and motor ability to drive, with a driving test. And then we keep them accountable with tickets and fines and, court after an accident, and so on and so forth. Now, the fact here is that the rules of the road, pay attention to this. So, people usually say that, oh, we have too many rules and, it's too complicated to write code that, that addresses all those rules. That is, in fact, is not the case. The rules of the road are not too many and are easily learned by 16-year-olds, right? And essentially the rules are who can drive what, when, and where, what speed, in what direction, who has the right of way, how to use and interpret signals, and where you can park and stop. Really, that's about it. So, for example, in our system, the number of rules that we use is 27, okay? And many of those are actually kind of like a duplicates of one another. So the point here is that it is very hard to code good behaviors. It's very hard to learn good behaviors, but something is very easy is assessing good behaviors. Essentially, if I'm given a candidate, a behavior or something that happened, I just check it against the rules and I know whether or not the driver was abiding by those rules, right? So this is, and if you think of it, this is exactly the same with NP problems, right? So what is an NP problem, right? So it's a problem where, it's very hard to come up with a solution, but once you have a candidate, it's very easy to assess whether the candidate is a solution or not, okay? So, and when I talk about accountable intelligence is a system by which we can go from the laws to an interpretation of the laws, to a precise specification into some form of, for example, formal language, implementation into code that translates into behavior. And so what we want to do is we want to go from laws to specification to implementation to behavior and back. So we want to know why the car did something. And also I want to make sure that in an audit, the system can be inspected and assessed against existing laws, right? So what we do in the company, or the kind of like approach that we've been, like pursuing, is something that is based on what we call a rule book. What is essentially is a collection of rules, okay, where each rule is a natural language description of the intent of the rules and where it comes from, plus a precise, rigorous mathematical description, including essentially the constraints under which that encode this rule and a violation metric. So essentially what I want to know is by how much I'm violating this metric, this rule. And the key point here is that the violation metric must be something that is monotonically non-decreasing, in the sense that violating a rule by more is worse than violating that rule by less, right? The key point here is that the rule book is not only a collection of rules, but is a hierarchical collection of rules, okay? Essentially with a partial order and weights, defining essentially preferences over or priorities between these rules. The point here is that all laws, all laws are equal, but some laws are more equal than others. Okay, so I'm paraphrasing, George Orwell here, and essentially the point is that it is commonly accepted that there are some rules that take priority over others, but we had to translate this commonly accepted into something that is actually mathematically sound. Okay, so then we come up with this like a partial orders. Okay, essentially, nobody will object that safety of humans, for example, is more important than comfort when you're driving. Okay, so then what we do is assume that some constraints may be violated. For example, because of somebody else's behavior. And now what you want to do is, by having this prioritized set of rules with rule violation metrics, essentially what you do is you have, for any given trajectory, any given behavior, what you get is a violation over all these priority levels. And essentially you rank behaviors according to a lexicographic order, meaning that a small violation of a high priority rule is worse than a small violation, than a large violation of a low priority rule, okay? And this is really what drives our choices. How do we do that? Essentially, we plan using unbridled creativity and good taste. The way to get good ideas is to get lots of ideas and throw the bad ones away. So let me go quickly in the interest of time. So essentially what we do is, we have in the planning and decision-making layer, what we have several trajectory proposers. And essentially what I'm trying to do here is to get essential coverage of all possible qualitative behaviors that I can have. Then we, for each one of these, we evaluate the violation of the rules or lack of violation of the rules, and then we choose based on that lexicographic order, meaning that I try to satisfy all rules if I can. And if I had to violate some, I prefer to violate low priority rules rather than high priority rules. And then this is what we feed to the vehicle and what we do, what we choose to do. So, okay, so this is really the point, right? So we have perception system translates sensor data into semantic description of the world. Planning is what we do is generate efficiently a collection of sufficiently diverse candidate behaviors. And here I'm not advocating one particular approach over another, just the point is to have as many sufficiently diverse candidates to evaluate. And then we have these arbitration layers where we evaluate candidate behaviors according to these rules of the road, choose a minimum violation, and then that's what we execute. Okay, so let me conclude here. Another key point is that ethics must be thought of as a marriage, not a wedding. The difference here is a wedding is not the one-shot event, okay, that you want to organize, arrange, have a grandiose wedding. Is the marriage. Is over decades, you had to work on every day on making the marriage successful. And the focus is not only on the product should be on the company and on the development processes and all the processes, right? So development, operation, and maintenance. Throughout, all of my activity, both as a university professor at, in our lab, and then with the startup, and then now with the big corporation, we have really emphasized a number of things. Engagement with the public, right? So we always wanted to do public pilots, really to promote transparency and awareness of capabilities and limitations. So we did the first ever robotaxi pilots, public pilots in Singapore back in 2015, 2016. Now, as I was discussing before, we've done hundreds of thousands of paid rides with the general public in Vegas. We publish these papers where we we do this voluntary self-assessment. We engage with authorities. We've been working with governments worldwide, in particular in Singapore, helping them develop these laws and the technical regulations for autonomous vehicles. We're engaged with the whole industry, right? So we are spearheading this notion that even though we are competing, we want to share data and lessons learned on safety critical aspects. Safety is something that will make all of our lives better if we can show that our vehicles are safe. We did our first, in industry first, we did a third-party certification. So essentially we called another company. We paid this other company to come and look at our stuff and really certify that that what we are doing is something that is conducive to safety. And then last is empowerment of our staff. What we have is what we call the red button policy. Anybody, the most junior intern can essentially hit the red button if he notices something that is a safety concern and essentially stop operations until we can resolve that particular issue. Let me stop here in the interest of time. I understand there will be questions and answers at the end of the session.
Yes, thank you very much, Professor Frazzoli, for this fantastic talk. I think the regulatory challenges are not often mentioned, so it was good to hear your perspective about them for self-driving cars. There will be indeed a question and answer session in 45 minutes.